Okay, so today we're going to talk about systems of equations that have three variables. Something that's true about if you want to be able to solve a system of equations, if you have three variables, you need three equations. If you have four variables, you need four equations. We're not going to do four variables and four equations in this class because it is a monstrous undertaking, but I think you'll get the hang of this with three variables and three equations. When we're talking about three variables and three equations, one of the things that I need you to understand is by bringing in that third dimension, we're talking about planes in space now, not lines on a two-dimensional graph, but planes in space. So the planes in space can intersect in different ways. In these three diagrams, you have three planes, and there is no single point of intersection. Right here, these are the kind we're going to do. This is the kind of system where you have three planes and a single point of intersection, and that's what we're going to be working with. Over here, you've got three planes that intersect on a line. We're not going to be doing any of those. Your textbook does have some, but we're not going to be doing them. So these are the only kind that we're going to do in this class. All right, let's go through an example. I like to use a little bit of extra notation when I'm doing these to try and help me keep everything straight without having to write things out 100 times because it takes up a lot of space to do this. So the first thing I'm going to do, I've got three equations, right? See three equations? I've got three variables, x, y, and z. This right here, that's like green. This is equation 1. This is equation 2. And this is equation 3. I'm calling them 1, 2, and 3 because as I refer to them later on, you'll know what I'm talking about because it's easy to get stuff all mixed up when you're doing this. The very first thing that I want to do is I want to start eliminating something. So let's go over here and we're going to write our steps. I got a ruler. I'm going to put a little line here. We're going to put all of our instructions. Over here to the left. Number 1. Pick one variable to eliminate. It doesn't matter which one you pick. Next thing we're going to do is start eliminating. We are going to use elimination twice. Use elimination twice to delete that variable twice. Okay, here's what I'm going to do. I choose z's. All right? I'm going to eliminate z's. You can choose y's. You can choose x's. It does not matter. I choose z. So I want to eliminate a z, and I got to use two equations to do it. So first thing I'm going to do, I'm going to take equation 1 and add it to equation 2. Would you agree if I add equation 1 and equation 2 together, z's will eliminate? Okay. So I have equation 1 plus equation 2. So I have 2x minus y plus z equals 4. And equation 2 is x plus 3y minus z equals 11. When I do this, the z's eliminate. Add my x's, and I have 3x. Negative y and 3y is plus 2y. And this is going to equal 15. This is a new equation that is now part of my system. He needs a name. We're going to call him 4. Okay, we got to do this again, because remember, we've got to get rid of that same variable twice. So I need to get rid of z again. I think the easiest way for me to do it is to take equation 1 and add it to equation 3. So I'm going to do 1 plus 3. All right, z's eliminate. I have 6x. Ooh, look at bonus! My y is actually eliminated. Equals 18. This right here, he is equation 5, and he gave us a lovely little bonus. And that is we can solve for x, right? Now, what we actually need to do, secondly, is solve the system with equation 4 and 5. Okay, so here's what we're going to do. We're going to start out with 6x equals 18. Divide by 6. We have x equals 3. Wow, got one variable. Now, we've got to solve for the whole system that's equation 4 and 5, right? So let's take this equation 4, and we're going to plug x equals 3 into this equation. Now, to help me keep everything straight, I'm going to put here 4. Because that's what I'm working with. So 3 times 3 plus 2y equals 15 gives me 9 plus 2y equals 15. Subtract 9 on both sides and I get 2y equals 6. Divide both sides by 2 and I get y equals 3. Look where we are. We got x and y now. Last step, substitute into 1, 2, or 3. Doesn't matter which one. And we're going to find our last variable. So I'm going to pick 1. So I'm going to write 1 because that's the one I'm working with. And I have 2 times x, which is 3, minus y, which is 3, plus z equals 4. So this is 6 minus 3 gives me 3, plus z equals 4. Subtract 3 from both sides, and I get z equals 1. All right, now I have to write this as a solution. So you're going to put these in alphabetical order, with commas, like so. So x is first, he's 3, y is 3, and z is 1. So that's my solution. They go in alphabetical order, x, y, and z. So if you have some with A, B's, and C's, they go in alphabetical order. All right, go down here. We're going to do this again. Go through another example.
Hold on. Well, let's say you have like 2b plus c minus 3a equals 7. Would you still put it in alphabetical order?
Can we talk about this later?
Okay.
Okay, cool. Thank you so much. All right. Next thing, we've got to label our equations. 1, 2, and 3. So remember, step 1 is pick something to eliminate and do it twice. What do we want to eliminate?
1 and 3.
That's what equations we're going to use. What are you eliminating?
X.
You guys want to eliminate x?
Yeah.
Okay. So you want to do 1 and 3. You can do some multiplying if you need to make it happen. Okay, so equation 1 is x plus y plus 2z equals 3, and we have negative x minus 2y plus z equals 10. So far, so good? Okay, x's eliminate. This gives me negative y plus 3z equals 13. So far, so good? Let's label that. That's 4. Okay, we got to eliminate x again because we have to do the same variable twice. What do you want to do?
Multiply 1 by 2.
Negative 2?
Negative 2, yeah.
Okay, let's do that. So we'll take equation 1 and we'll multiply it by negative 2, and we'll put that with equation 2. Sound good? Nice way to write it so my teacher knows what the heck I'm trying to do. So negative 2x minus 2y minus 4z equals a negative 6, and 2x plus y plus 3z equals 7. My x's are going to eliminate, and I have negative y minus z equals 1. And this is equation 5. All right, the next thing I need to do, take my system that is made up of 4 and 5, and I got to solve the system. So I got to solve for y and z. So how do I go about solving the system made up of 4 and 5? Would it help if I do this? There we go. Now we can see it easier. What can we do?
Multiply by negative 1.
Okay, so here's what I could do. Take 4, multiply that guy by negative 1, and add it to 5. Perfect. So this is going to be y minus 3z equals negative 13. And then I've got negative y minus z equals 1. The y's eliminate, and I have negative 4z equals negative 12. Divide both sides by negative 4, and I get z equals 3. Fair enough?
Yes.
All right. So next thing we're going to do is we got to go ahead and solve for z. Or we did z, we got to solve for y, because we have to solve for everything in 4 and 5. And you know how to do that. We're just going to substitute. Pick 4 or 5, it doesn't matter which, and substitute in. So for example, I can pick 4 and say negative y plus 3 times z, which is 3, equals 13. So that gives me negative y plus 9 equals 13. Subtract 9 from both sides, and we get negative y equals 4. Divide both sides by negative 1. Y equals negative 4. There we go. Last part we need to do. Pick 1, 2, or 3 and do substitution to find your very last variable.
So I think we should do 2, 3, and multiply 2.
No, you don't need to be doing the multiplying. Your simple substitution. Take equation 1, right? Do we have x? No, that stays an x. Do we have y? Yes. Plus a negative 4. Plus 2 times z, which is 3, equals 3. That's all we need to do. We're just going to substitute and get this answer real quick. So I have x minus 4 plus 6 equals 3, gives me x plus 2 equals 3. Subtract 2 on both sides, gives me x equals 1, and we're done. All we have to do, write our answer, x, y, z.